Bonjour. Welcome to Wahsa Distance Education Center's radio Zoom classes. This is MEL3E, grade 11 workplace math, and I'm the teacher, Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You are always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday, 9 until 10 in the morning, and we are in our 7th week of our 9-week course. At this point, you definitely need to be submitting work to get your credit. So a reminder that the practice problems, the ones with the little pencil icon, are not for marking. These are just for you to do to practice to make sure you're understanding the concept. So you can decide which ones and how many to do. It is okay to skip some if you are understanding the concept. You don't have to do them all just because they're there. But also, if you need more practice, let me know and I'm happy to send you more practice. The key questions, the ones with the little key icon, these are the ones to submit for marking. So these ones you need to do all of them. I'm marking them all, so please do them all. Also, please show your work. This way I can understand what it is that you truly understand. And if you're struggling with something, it gives me more information so that I can actually help you. More information is better. So how do you submit your work for marking? There's 3 methods. The first is to scan your work and send it electronically. If you have a device, you can scan it using those devices. The Apple devices come with a Notes app, and the Android devices come with a Google Drive app. These are free apps that are really fairly easy to use, basically point and shoot. But if you need help, I've made tech tutorials on my YouTube channel that walk you through step-by-step how to use these apps. And if that is not enough for you, then let me know and I'm happy to help you. We can figure it out together. Then once you have a file, you can send it to me either through email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca. Or you can send it to me through Facebook, where my name is B. Slate Wahsa. The second method is to drop your work off into Lookout. We have an outdoor mailbox at our 74 Front Street location. We are the bright red building next to the post office and have a small white mailbox next to our side entrance. So just stick your work in there at any time and I'll get back to you as soon as I can. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students are also welcome to fax in their work. Just give us a heads up that it's coming because sometimes things get lost. If you want to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. All of our radio Zoom classes are recorded and I upload them shortly after broadcasting to YouTube and then share them on Facebook. So this is a really easy way to find all of our lessons so that you can review them or watch them as needed. Also on my YouTube channel, there are short videos that explain common errors and confusing concepts that can be really useful tools if you're struggling with something. Math is a really visual subject, so I strongly encourage you to access the videos, either joining me live and watching on Zoom. You don't have to talk to me. It is fine to just join and watch, no worries, or watching the YouTube videos on your own time when it works for you. Those are both totally legit options. If neither of those work for you, let me know and I'm happy to send you a copy of the recordings so you still have the full experience and can really set yourself up for success. So if you have any questions, please reach out and connect with me. You can email me at bronwyn.slate@nnec.on.ca. You can, connect with me through Facebook at B. Slate Wahsa. Call me at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., though I teach from 9 until 11, so that is not a good time to try to get a hold of me. All right, today's lesson is lesson 17, and we're looking at traveling distances. Our learning goals are that at the end of this lesson, you will be able to use a paper map to estimate travel distances. You'll be able to use an electronic map to estimate travel distances and predict travel duration. And you will be able to understand how weather conditions influence travel times. So you know you met these learning goals because you can use the given scale on a paper map, as well as the given data to measure distances between places. You can use Google Maps to find distances and estimated distances of travel times. And you can explain how bad weather results in longer travel times. So when will you use this in real life? Well, we're learning how to make decisions and also justify them. So we're doing that as a whole in this course, not just in this lesson, but being able to be confident in the decisions that you are making and know the reason why you're making those decisions is essential for surviving life. Being able to explain them is really key in terms of communicating with other people around you. But first, let's activate our brain with some mental math. I don't believe in math minutes. They cause stress and anxiety. They don't set folks up for success. They're not a great idea. So instead, we work on developing strategies that help individuals get comfortable and confident with manipulating numbers based on the skills and the tools that they have. So today's question is 491 divided by 11, and we're using the strategy of multiplying up. So this is the idea that instead of taking our things and breaking them up into our groups, thinking about how many groups of our smaller amount can make, how many groups can make our total amount. So we're going to have, so we can think about, okay, if we have 10 groups of 11, that equals 110 things. Okay, so not enough, but I can see that if I have 40 groups of 11, well, that's just going to be 4 times 110. So that's going to be 440. So I'm getting closer. So I know it needs to be more than 40 groups. So then I have 51 more things to do. So I'm going to say, well, if I have 44 groups of 11, well, this is only 4 more groups than 40. So that means I have 44 more things. So that's going to be 484. And then I only have 5 more things. Sorry, not 5 more things. I have 7 more things until 491. So I have a remainder of 7. So this is going to be 484 with a remainder of 7. So using multiplication means that I was able to go up in friendly groups in order to figure out what I have and how much is left over. So that can be a great strategy to use. So knowing your multiplication tables does help. All right, mine's on. What do we need to set ourselves up for today's lesson? I wanted to remind you about cross multiplication and dividing. We're going to be looking at some ratios today. So this is just a little bit of a reminder. I don't love this because it's just sort of procedural. So it's just sort of steps, but it can be a useful tool. So with cross multiplying and dividing to solve for an unknown. So here we have 8 over 12 equals x over 30. So there's a couple of different ways that we can do this, but cross multiplying is one tool. So that means that we multiply the denominator times the numerator on one side and the denominator times the numerator of the other sides. They're opposite sides, they're across. So we have 8 times 30 equals 12 times X. 8 times 30 is going to be 240 because 8 times 3 is 24 equals 12X. And now we divide both sides by 12 in order to isolate for X. 240 divided by 12. Well, 24 divided by 12 is 2. So 240 divided by 12 is going to be 20. So we find out that our unknown is equal to 20. So that what does that mean is that the ratio of 8 to 12 is equal to the ratio of 20 to 30 is what we're trying to figure out. So cross multiplying can be a useful tool. Basically, you're just doing algebra, but it's sort of a different way to think about algebra. Then here we have 63 over 108 is equal to 9 over y. So again, we multiply across our numerator times denominator across the equal sign and our numerator times the denominator times across the equal sign. So we have 63 times y is equal to 9 times 108. Well, that's going to be 63y is equal to 9 times 108 is going to be 972. And then divide both by 63. And we get, this is not something that jumps out at me in terms of, so we can just use our calculator. We could do some simplifying, or we can just use your calculator. It is totally legitimate to not do simplifying all the time. So we get 15.4. So y is equal to 15.4. So what that means is that 63 over 108 is the same as 9 over 15.4. Sorry that that's messy. And that's cross multiplying and dividing. If it works for you, great. If it doesn't, we can work on developing other tools that hopefully makes more sense for you. Okay, so then let's look at comparing ratios. So that is how we calculate with ratios. But here we have a situation. So we have Darnell and Lester took a fishing trip on their with their scout troop last weekend. Darnell caught 4 catfish and 8 trout. Lester caught 3 catfish and 6 trout. Did the boys catch the same ratio of catfish to trout? So to compare, so we're doing catfish compared to trout. We can write it like this, where we have our colon. We can also write it as catfish over trout. These are just different ways of writing ratios. So for Darnell, we had 4 to 8. We write it in the same order. So we don't have to write catfish, we write 4 to 8 because we're talking about catfish to trout. We know that that's 4 catfish and 8 trout. Whereas Lester was 3 to 6. So here we can simplify this. We can see that both of these is for every 1 catfish, they caught 2 trout. Because 4 to 8 simplifies to 1 to 2, and 3 to 6 simplifies to 1 to 2. So they did catch the same ratio. So even though Darnell caught more fish, he didn't have more catfish compared to trout as Lester. They had the same ratio of fish to trout. Sorry, catfish to trout. Another one, Regan and Tisha are using roses and carnations to arrange bouquets for the Bud Time Flower Expo. Regan plans to use 6 roses and 4 carnations, and Tisha plans to use 5 roses and 3 carnations, whose bouquet will smell more like roses. So again, comparing these ratios. So Regan has 6 to 4. And Tisha has 5 to 3. So these ones, we can simplify 6 to 4. We can say that that's 3 to 2, because we can both, for every 2 carnations, we have 3 roses. But here for Tisha, these are both prime numbers, so we can't simplify that. 5 to 3 is the simplest that we can have. So for every 3 carnations, there's 5 roses. So these ones are not exact. The ratios we cannot get in the same base, but what we can do is we can write it the other way, and then we can do it with a, we can turn it into a percentage. So 3 divided by 2 is 1.5, which is equal to 150% of roses, because roses is the top one. So then 5 divided by 3 is equal to, I don't actually know what 5 divided by 3 is. Oh, yes, I do. So 1.67, so is equal to 167% roses. So Tisha's bouquet has more, is going to smell more like roses, because it's got the bigger percentage of roses compared to carnations. So sometimes there's more than one way to do it. The key is figuring out what the question's asking and what your best tool is going to be for comparing those ratios. All right, so let's look at some new concepts today. So first, we're going to talk about estimating distances on maps, and this is on page 16 of your IO booklet. So rarely in real life are there 2 places on a map connected by a straight line. So generally we can estimate to use to figure out how far 2 distances are, just because it doesn't, measuring is going to be hard to get exactly right. So an estimation can usually give us enough information. Then on maps, there's what's called a scale, which shows the size of the area that's represented by the map in comparison to real life. So this is, obviously maps are not life size, and they're representing distance. And so that scale tells us how the measured distance on the map compares to in real life. So to estimate effectively, a scale must be given on the map to calculate the distances, to give us an idea of how big or small that map is in comparison to real life. The scales are usually given in one of the corners of the map. Usually they look fairly similar. Here is a paper map. So this is a map of Northwestern Ontario. As you can see, it's got lots going on. So the scale we can find is here. This little piece here, it says map scale, and it shows you both kilometers and miles. It says 1 centimeter is equal to 16 kilometers, or 1 inch is equal to 25 miles. So we can, if you were to measure this here, we would see, we could use that information to measure on the map. They also give you this scale, which is 1 to 1,600,000. So that's saying that for every 1 unit, so for every 1 centimeter, it's in real life, it's 1,600,000 of that same unit. So 1 centimeter, so it's 1 centimeter is equal to 160,000 centimeters in real life, which is 16 kilometers. So any paper map is going to have some sort of scale that gives you some information on it. On Google Maps, on a digital map, you can see that scale is down here in the bottom corner. If we actually go into Google Maps, that scale, see, once again, is down here. It changes. So because right now we're saying that this distance here is equal to 200 kilometers in real life. But if I zoom in, they changed the scale. So now this distance is equal to 100 kilometers. And as I get closer, now that a similar distance is equal to 50 kilometers. And now it's equal to 20 kilometers. And now it's equal to 10 kilometers. And you can see the distance, the unit of measure here changes as well. So it's not always the same size. So you need to be paying attention. So that here in the bottom right corner is the scale on Google Maps, on a digital map. In your IL booklet, this is the scale here that they printed. It's pretty simple. So it's just saying that from here, from this distance to here is 5 kilometers, or you can say from this distance to this distance is 2 miles, depending on what unit you want to be using. So then you would measure, we'll go through that, but that's where that you can see the scale in your IL booklet. So they can be really detailed or really simple. Okay, so how do we actually estimate distances on a map? So the first step is to measure the scale given on the map and write it as a ratio. I'm going to talk about the steps and then we're going to go through an example. Step 2 is to use a ruler to measure the distance from the 2 points. Only measure straight-ish distances. So you might have to do a bunch of different little bits on roads. We're talking about roads. We're not talking about as the crow flies or like linear distance. Step 3 is to add the estimated distance measured together. And step 4 is to write an equation with the scale on the unknown x to represent the distance in kilometers. Step 5 is to solve for x using cross multiplication and divide. So let's see what that actually means. So for example, when we have to estimate the distance from the Jeremiah McKay Kabeshiwekamic, sorry if I'm saying that wrong, number 2 hostel to Fresh Market Foods. So from hostel to Fresh Market Foods. So our first step, remember, is to measure the scale on the map. So that is, I've taken this off of, a screenshot of this off of Google Maps so we can see the scale is down here. So I bring up a ruler and I see that 200 meters is equal to 3 centimeters. So I'm going to say 200 meters equals 3 centimeters. I'm going to keep that written down. Okay. So then I'm going to now measure using my little ruler distances. So I have going from hostel 2 to First Avenue to the main road is 3, and these are centimeters. Now we're talking about what we're actually measuring. So we have 3, and I'm gonna write them down as we go because I want to keep track. So I have 3 plus, then up first to where the roundabout is now is 8.4. And then straight from there is about 12 till where Tim Hortons is in the big turn. Again, there's a little bit, some wiggles here and there, but that's okay. We're doing, this is why we're estimating, because it's a rough approximation. And then up Wellington Street from Tim Hortons up to where the Legion is, the big turn again, is 8.2. And then from the corner to the turn to Fresh Markets Food is 0.4. And then up from Front Street to Fresh Markets Food is 2.6. So I had measured all these before, but you can just see that what I'm doing is I'm measuring from where the road is to my destination and then saying, okay, that's 2.6. That's what I'm measuring this distance here. And again, we're estimating, so it's okay if it's not perfect. So then what we do is we add all of these up, right? So we have all our bird distances, and now we're going to add them up. So we have 3 plus 8.4 plus 12 plus 8.2 plus 0.4 plus 2.6 is equal to 34.6 centimeters. So we know that that distance, if you were to drive it or walk it on the map, if you were an itty bitty little person, it would be 34.6 centimeters. But how is that helpful for us in terms of actually real distance? Well, that's when we go back to our scale. So we say 200 meters is over 3 centimeters is equal to X. How many real meters is equal to 34.6 centimeters. And then this is when we cross multiply and divide. So we do 200 times 34.6 is equal to 3x. So 200. Oh, my calculator was still there. 200. Oh, it's not working. Times 34.6 is equal to 6,920. It's equal to 3x. So then divide both sides by x, or sorry, by 3. And we get 2,306.67 meters. Sorry, I ran out of space. So I'm going to write it up here. So the distance is about 2,306.67 meters. Oh. And there we go. So sorry about squish space, but that's how you would estimate on a paper map. I've used Google Maps so that we have a picture of a map, but using a ruler to measure each of the little distances is how you'd estimate that distance. All right, example 2, if we are estimating from town to town, so we're estimating the distance from Mishkagogomem to Sioux Lookout. Again, here we see this time our scale is 20 kilometers equals 2.4 centimeters. And then now we need to follow along on the road. It's hard a little bit to see the roads on this map. Hopefully, if you're doing this, you're going to be able to see better on your map. So we have 1.6 plus 12 plus 5.6. Again, we're estimating, so it is okay that like this road has a lot of wiggles and woggles. It's okay that we're not following all of the wiggles and woggles. Plus 5.8. I think that gets us right to Sioux Lookout. So we're going to add those together. So add them together. And we get 25. So we've measured 25 centimeters. So then to convert it to kilometers, so we have 20 kilometers is equal to 2.4 centimeters is equal to X or D or whatever letter you want, M is equal to 25 centimeters. So then we cross multiply, we get 20 times 25 is equal to 2.4x. Well, 2 times 25 would be 50, so 20 times 25 was going to be 500. So then divide both sides by 2.4. And we get 500 divided by 2.4 is equal to 208.3 kilometers. So the distance is 208.3 kilometers. And that's how you use a map to estimate distances and ratios to use the scale to calculate. All right, so now you can do the support questions on page 18, questions 1 through 3. I just want to do a little bit of understanding paper maps. We'll go through it quickly just because we don't have a ton of time, but I think it's important to understand paper maps, even though we don't use them all that often. Still an important tool. So on paper maps, there's 2 sides usually. This Ontario one has Northwest Ontario on one side and Southern Ontario on the other side. You can see there's lots of information there. They have a legend, so it'll always tell you what all of these symbols and lines mean. So you can see here on the Southern Ontario, there's like all of these tons of red lines. So the legend tells us what they mean. That here's a legend here. Legend might be on the back on one side or the other, but the legend will be there and it'll tell you what everything means, all the symbols mean. So they tell you things like the size of the highway, the size of the town, any sort of travel and tourist sort of information where airports or ferries, provincial parks, things like that, hospitals, things like that are. Then also on paper maps, there is this distance triangle often in the top corner. So it helps you, instead of having to measure, it helps you give you estimations. So if we zoom in here, let's see, okay, so we can see we can see the distance from Kenora. So how it works is that we find one place. So here, let's say Kenora. And we want to figure out how far it is from Kenora to Fort Francis. So what we do is we look, Fort Francis is this line here of information. So we go across until Kenora is this line of information. So we can see that it's 215 kilometers, roughly. Everything's rounded to 5 kilometers. So the same idea is that if you want to figure out how far Sioux Lookout is from Toronto, so we go, Sioux Lookout is here, we go across to Sioux Lookout, we go up from Toronto until we meet, and it's here. 1,745 kilometers between Sioux Lookout and Toronto driving distance. So that can be a useful thing instead of having to measure using your ruler. It can be really helpful to just use this little chart. Then also in paper maps, there's these little inserts, which are zoomed in areas. So we can zoom in a little bit more to see. So this is our area. So we can see here Sioux Lookout and Dryden, Anakokin, Fort Francis. So you can see how all that information is there, which can be hard to see on the big, huge map. That's this area here. It's hard to see in this one, but one of these little inserts here is zoomed in on our area. So that's how maps do it, because they can't actually zoom in. So then here, the other thing is that they have distance written on. So instead of actually measuring with a ruler on a map, they have these little stars that tell us between this star, this little red star here in Sioux Lookout, and this star here, where at the intersection of 516 and 599, this distance is 104 kilometers. And then from this star again, all the way up to the next star, which is in Pickle Lake, is 156 kilometers. So we can see that that's 260 if we add those together, 260 kilometers from Sioux Lookout to Pickle Lake. So we can use that information to sort of estimate how far it is to Mish. So that can be useful, again, instead of having to write out on all of to measure with a ruler for everywhere and use the scale, using those little red numbers that are between the stars. The stars tell you those distances. Here, if we zoomed in on, we can see here to estimate from Wabigoon to Ojibwe Nation of Saugeen. So from Wabigoon to, again, we don't have a star right at Wabigoon, so we sort of we're estimating. So from the start to Norwick, it's 60 to 5 mile, and then 8 kilometers to Sioux Lookout, so that's 68. And then from there, it's 104. So now we're at 172. And then on to Saugeen, it's another little bit. So then you could maybe say, well, you could say it's 180 because we're estimating approximately, or 185 because there's a little bit here and a little bit there. So that's how you can use those to estimate information. Okay, so then next we want to look at estimating distance using technology, because we've advanced to not just having paper maps, but we can use technology, which is on page 20 of your IL booklet. Because we can use the internet. If we have access to the internet, we can use it to estimate not only distances, but also driving times. So the most common site that I use and that I think many folks use is Google Maps, which is google.com/maps. And this is what we've already been looking at a bit in today. So if we do that, we can use that information. We can use Google Maps to estimate distances. So if we're going from Red Lake to Ignace, that's not what I wanted you to do at all. Wrong button. This is what I wanted. There we go. Okay, so what you do is you click here where it says directions, and then you can start a starting point and a finishing point. So we wanted to go from Red Lake, Ontario, to Ignace, Ontario. And then it zooms in, and then it shows us the road that they suggest that you take. And they tell you that it's 321 kilometers, which is approximately 3 hours and 37 minutes right now. This can change a little bit if there's like traffic or construction. That number might change a little bit. The kilometers will still be the same because the distance doesn't change, but the time, the duration might change. And that's all you do. So you just put in your first location, your second location, hit enter, and it shows you. So then if we want to try to go from Dryden to Sault Ste. Marie, try another one. So we put in Dryden. Oh, you can also change it in terms of if you're walking or biking or taking public transit, if that's something that's useful within the place or whatever's useful for you. So we want to do Dryden. Not sure why it's not going to let me type. Dryden. There we go. I'm sorry, my tech is giving me issues. So Sault Ste. Marie, there we go. And then we can see here they give us options because you can fly from Sioux Lookout. So they can say you can get to Sioux Lookout, you can drive to Sioux Lookout and then fly. That's the straight line. Or you can drive from Dryden. And then it's 11 hours and 20 minutes, approximately 1,032 kilometers. So that information is all there. So that can be a really useful tool. And that's what you need to use for question 4 on page 22. If you don't have access to the internet and you can't access Google Maps, let me know and we can figure out a different plan for you. So the last piece is just talking about how travel time can change. So basically, you need to be safe. So if you're driving at night, you need to slow down because your stopping distance, how long it takes you to stop, is dependent upon how fast you're driving. So this image is showing you that when your low beams are on, they show you 45 meters in front of you. If you're driving 70 kilometers an hour, it takes you 40 meters to stop. So if I slam on the brakes right here at this point, because I see a person on the road, it's going to take me 40 meters to stop. I don't stop right here, even though I press my brakes right here, because of physics, it takes a while for a vehicle to slow down. But here, if I'm driving 80 kilometers, I see this person as soon as they come into my vision, into my lights, it's 45 meters away, and I hit the brakes right away. Because I'm traveling 80 kilometers an hour, it takes me 60 meters to stop. So there's nothing else you can do, just the physics behind it. It takes that long for your vehicle to stop. So you need to slow down at night in order to be able to stop when you can actually see a post stopping where the vehicle needs the time to stop and you can't see where you're going to end up. The same goes for if your roads are wet. So the same idea is that you react. There's always a bit of a reaction time, a couple of seconds. And then on dry roads, the car can stop faster than on wet roads. So at 40 kilometers an hour, it generally takes 17 seconds to stop, to process, to react. So it takes 9 more seconds, which at this speed is 26 meters on a dry road. And it takes 13 more seconds on a wet road because you're going to skid a bit more. So that's 30 meters. If you're driving 110 kilometers an hour, it's going to take you longer to react because you're going to go farther distance because you're traveling at a faster speed. So you react, you're going to travel farther while you're reacting. And then when you stop, because of physics, again, you're going to go farther while your foot's on the gas and you're actually stopping. So on a dry road, that's going to be 113 meters. And on a wet road, it's 143 meters. So at 110 kilometers an hour. So that's a big distance if you feel like you need to stop for something to get out of the way, like a moose. So it's just important when your roads are wet, slow down. Basically, anything that's happening, any sort of weather, slow down. If it's wet because it's raining, slow down. If you're on packed snow because it's winter and so the road is covered in snow and it's snowing, slow down. You're going to take longer to stop. If it's icy because it's transition time and it's freezing rain, slow down. These are all overall, slow down. The weather is not great, slow down. Also, your tires have an impact. So again, you're going to slide farther on summer tires in the winter than on winter tires. And also all season tires, you slide farther as well. So again, be conscious about that when if you have those different types of tires on your vehicle, slow down. And here I just have some pictures of like visibility and how different types of weather make it harder to see. And therefore you shouldn't be driving fast because if you can't see, you can't stop if something's in there. There's all sorts of these memes out on the internet that show things like how ridiculous it is that people, as soon as it starts to snow, end up in the ditch. But this is because people are not slowing down and driving for the weather. So basically, slow down. That is the long and the short of it. Okay, let's consolidate what we've learned today. So our lesson 17 is traveling distances, what we've been looking at. So we looked at estimating distances on a paper map using the scale that's provided, as well as the given distances of those little red numbers. And then we looked at estimating distances with technology, specifically looking at Google Maps. You don't have to use Google Maps. You'll probably get the same information. That's just something that is free and most of us have access to. Then the travel time piece is that it's going to take you longer. In bad weather, it's going to take you longer to get places because you need to slow down in order to arrive safely. That is the overarching general theme. The only thing you need to remember, slow down. It's going to take you longer. Better to arrive alive than not to arrive at all. So hopefully you are comfortable that you can use the given scale and the given data to measure distances between places. And you can use Google Maps to find distances and estimate those travel times. And then also you can explain why bad weather results in longer travel times because you're driving slower. So if you have any questions or you want to chat with me about any of this, please reach out and connect with me. Call me at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. You can send me an email at bronwyn.slate@nnec.on.ca or connect with me through Facebook at bslate-wahsa. Remember, I have a YouTube channel that's also called bslate-wahsa, and we have a playlist called MEL3E, where all of our radio Zoom classes have been recorded and uploaded there, so you can access them whenever works for you. Thank you so much for joining me today. I hope you have a lovely day. Which